What is universal automation all about? And more importantly for some, is it worth it?
I think this universal approach to automation is the right path to take. As a company, we're definitely benefiting from the fact that we can program something once. It's definitely a revolution for us. We're taking a completely new approach that opens up a whole host of opportunities.
There's something fascinating about automation. Our eyes light up at the sight of technical systems manufacturing and packaging products.
When you go to the supermarket and look at the cheese or milk, it might seem like a simple product at first. But when you think about all the technology that goes into packaging the cheese or milk that way, that's one of the things that interests me the most. Kurt Bettenhausen from the Association of German Engineers once described automation as the technology under the hood. In other words, automation makes it possible for us to create and manufacture different products, and at a reasonable price.
Where does that leave humans? Humans are needed to automate a system, to orchestrate all the moving parts, to give the movement a sense and purpose. But in order for automation to ultimately offer an economic benefit, it has to follow certain rules.
You can put it in really simple terms. You've got the mechanical elements that keep the process moving. You might want to get a product from A to B, adjust something, or screw things together. You've got all the servo technology for the moving parts. Then there's the drive technology, and, of course, the control system.
Automation engineer Pierre Berkla is essentially describing the basic elements of the automation pyramid. This structure can be illustrated using a simple conveyor belt application. Starting right at the bottom, on the process level, you'll find the mechanical elements. These are moved using actuators such as servo drives, either forwards or backwards. However, other automated functions are also required for conveyor belts. For example, an automatic stop. This function requires an interaction between actuators and sensors. In this case, this means a light barrier also has to be installed. Actuators and sensors are connected to the control level via a field bus. This is how they send or receive signals. Nowadays, programmable logic controllers are almost always used at the control level. These run a coded algorithm known as logic. This logic determines when each of the mechatronic components should move. The code changes depending on the input signal, which means the actuators receive different commands. This is how the conveyor belt can automatically change direction.
The
basic idea of a programmable logic controller, or PLC, goes back 50 years, or almost 50 years. It's a cyclical system that starts at the top, works through all the logic right down to the bottom, then repeats the process in a continuous circuit.
Patrick Eickhoff has been working in automation for 21 years. He's a software developer for a mechanical engineering company called GEA. If you want to understand how automation works in practice, he's the right person to ask. He thinks that PLCs have some key advantages.
That's why the industry has such a high demand for classic PLCs, which have been working the same way for 50 years. They're robust, sturdy, and incredibly reliable.
GEA develops state-of-the-art separators for sectors such as the pharmaceutical industry. Aspects such as IT networking and artificial intelligence are extremely important to customers today. And this is where classic PLCs are faced with a challenge.
If we think about the shift towards analytics and AI in the modern world, there are quite a few customers who want a system module that more or less optimizes itself. And that's where a classic PLC reaches its limits. A PLC is simply not designed for those IT and software applications.
However, it is precisely these applications that are required today. After all, industrial companies are facing enormous challenges: supply chain problems, skill shortages, energy shortages, customization requests. The list goes on. That's why digitally networked factories and reconfigurable systems have become a key ingredient for success. But when it comes to such flexible modifications, the classic PLC approach reaches its limits.
Das würde also bedeuten, ich muss die
I have to take the entire system out of operation, load a new PLC program onto it, then recompile the program and download it for each controller. Then I have to test the program I've developed with the actual hardware.
Hardware testen muss, wenn ich verschiedene Hersteller.
If I have different manufacturers, I have to make sure they can communicate with one another. Then I have to turn everything on, boot everything up, and hope the system functions as it's been programmed to do.
Ein Programmiernutzen erfüllt.
But I don't always have luck on my side.
These difficulties are caused by proprietary systems. In a PLC, hardware and software are linked for specific manufacturers.
Man möchte die und die Hardware einsetzen.
If you want to use a certain piece of hardware or a certain processor, it has to be implemented in that exact development environment. All development environments work a bit differently these days. There are certain standards, yes, and it's kind of the same logic at the end of the day, but it has to be implemented differently.
Muss anders umgesetzt werden.
This is what makes a PLC's programming fundamentally different to the way software programs work in the IT world. In the case of laptops or smartphones, you have practically the same hardware from different manufacturers.
Aber die Software, die drauf
But
läuft,
the software running on them is often the same. You just have to look at Google with Android. It runs on so many different platforms and systems that it doesn't matter what kind of television you buy. It can be a Samsung or an LG. An Android system will always be running in the background.
Fernseher kaufe, im Hintergrund läuft immer noch ein Android-System.
When you talk to Patrick Eichhoff, you soon realize it's becoming more and more difficult to meet today's requirements with PLC-based automation.
Ja, das Aufwendigste gerade ist,
The most complicated thing at the minute is when you have a system consisting of many different modules from many different manufacturers that use many different controllers, and you want to bring them all together under one process control system. In cases like that, the system integrator basically has to write another software module, an adapter module, a gateway for each and every module or controller.
Adapterbaustein, ein Gateway mehr oder weniger schreiben.
In practice, this often makes it impossible to realize the full potential of automation technology. This is backed up by a recent study conducted by McKinsey. A lack of interoperability is identified as one of the main factors that is inhibiting growth in the Internet of Things. This is clear to Eichhoff.
Da muss was verändert werden, ja. Weil ich auch einfach sage, diese Anforderungen.
Something has to change, because it's not just customer requirements that are changing. The next generation of engineers is changing as well.
Ingenieuren ändert sich.
Professor Stefan Schaefer is closely involved with the next generation of engineers. He heads the electrical engineering department at the University of Applied Sciences in Berlin. He finds it extremely important to promote diversity in his teaching.
Wenn ich meine Studenten nur in ein einziges
If I only introduced my students to one universe of automation technology and they only learned about one tool chain, they'd be stuck in that school of thought and wouldn't learn that the world is much more flexible, broader, and more diverse than one single type of system.
Also als würde ich jeden Tag Hähnchen essen.
That's why Schaefer covers topics such as interoperability and software migration in his lectures.
Und wir wollen eben genau diese Migrationsstrategien.
And we actually want to teach our students about migration strategies and ways of combining different devices with one another. This topic has really gained in importance in recent years, and we get the impression that it will only get even more important in the future.
Thema noch wichtiger wird.
Letztendlich die Automatisierungstechnik ist
Automation technology is ultimately the same as IT, but 20 years behind. That's what I've always found anyway. And I think it's time for that to change. It really has to be on the same level. You shouldn't have to implement a separate interface to marry the two worlds. I think that it should really work right from the outset. At the end of the day, the IT world should be compatible with the automation world. But that's just not the case right now.
dass die IT-Welt mit der Automatisierungswelt kompatibel ist. Aber das ist aktuell einfach nicht der Fall.
It's clear to see that the current generation of engineering graduates have grown up in an IT environment. That's a really big difference to the older generations, who programmed in assembly language. That gives the younger generation certain advantages. They want to enrich their automation technology with the things they know from IT. And that's where you can now see young employees putting a lot of pressure on their companies to do things differently.
Merkt man schon, dass der Druck von den jungen Mitarbeitern schon sehr stark ist, Sachen anders zu machen. Ne?
Es ist alles da, aber es wird halt nicht genutzt, weil man...
It's all there, it's just not used. Because there's still a lot of conservatism within the industry. And that annoys me at times, to be honest, because you hit restrictions so quickly that it's just not fun to develop beyond a certain point, because it just gets too complicated.
bestimmten Punkt hinaus zu entwickeln, weil es halt einfach umständlich wird.
But is there a solution to this problem? Can we rethink automation? In answer to this question, Professor Schaefer mentions an automation standard that is currently undergoing a revival.
Da würde uns in Zukunft hoffentlich
We hope that IEC 61499 will help us in the future because it follows a different paradigm. The idea behind the revival is that we'll be able to design and develop universal function blocks that can run on any hardware platform.
egal ist, auf welcher Hardware-Plattform sie läuft.
The IEC 61499 standard, defined back in 2005, was initially intended as an extension of the current IEC 61131 standard. And yet its approach to automation is revolutionary because it's all about decoupling hardware and software.
Also die 16499 unterstützt erst.
First of all, 61499 supports a network approach to resources and plants, and that is exactly the change from the classic rigid automation pyramid to a production network. So this aspect of engineering is supported.
Der Engineering-Aspekt wird natürlich unterstützt.
Gregory Bucco belongs to a generation of automation engineers who have always been surrounded by smart factories and Industry 4.0. He wants to make industry fit for the future with a vision that is closely linked to an IEC 61499 automation approach. Mainly because he wants to separate the life cycles of hardware and software.
Und das ist heute, was wir als Schwierigkeiten,
Those are the difficulties we're seeing for many customers and end customers today.
quasi das
The
Lebenszyklus.
life cycle of their program depends on the life cycle of their products. We're looking to change that with universalautomation.org.
Werden wir das quasi ablösen.
Universalautomation.org is the name of the nonprofit organization that Bucco is working for. It wants to spread the word about automation based on the IEC 61499 specifications. A number of renowned industrial companies, manufacturers, and universities are already on board.
Also die Technologie ist schon da, die ist jetzt bereit.
The technology is already in place, and now we have the network and bandwidth to support it. What else did we need? A community to show support and spread the word. And that's where universalautomation.org comes in, as the community that can share and support the idea.
Breiten kann, unterstützen kann. Der Grund für Universal Automation ist richtig.
Our ultimate goal is to facilitate universal automation, going one step further than open automation. But we also want to enable application portability.
Und diese Portierbarkeit von Applikationen zu schaffen.
If we want to understand why Bucco and universalautomation.org and Professor Schaefer and his students have such high expectations of an automation approach based on IEC 61499, we should take a closer look at its specifications. The automation vocabulary used in the standard is no different. The basic terminology is the same. However, the standard redefines the concepts behind the components and how they are related to one another. In other words, IEC 61499 describes a different mode of automation, a different paradigm, so to speak. This paradigm shift becomes particularly obvious when you compare the relationship between hardware and software. In IEC 61499, hardware and software are decoupled. This results in a hardware-independent software environment in which applications can be freely modeled. This software environment and the hardware used later in the process do not have to come from the same manufacturer. That's what gives automation, according to IEC 61499, its universal and software-centric character. If we take another look at the conveyor belt application, this would then be as follows. The required function blocks are taken from a library. For our conveyor belt application, these function blocks are digital input objects for the light barrier, limit switch, and push button. We also need a block that defines the connection logic. The individual components are logically connected via bidirectional interfaces, shown here as orange lines. This shows how we can use the function blocks to create a kind of virtual twin of our application. However, function blocks in IEC 61499 are not just written for one specific controller and can be used by more than just one specific controller. The software objects are not tied to a specific piece of hardware. This makes it really easy to reuse them. The basic functions for a conveyor belt application are all contained in the Schneider Electric engineering tool used here. Let's take the motor, for example. All aspects of a motor application are encapsulated in the ready-made function block for the motor. The different code levels can also be viewed if necessary. This means that project engineers don't have to write any complex code. They can just work with a ready-to-use function block. This makes engineering much less complicated. We don't have to reinvent the wheel again and again.
Hardwareunabhängig zu sein oder System.
For us, universal automation is all about not being tied to any specific hardware or system. We can program a process, a machine, or skid in one environment, and it doesn't matter which hardware we ultimately decide to use.
Individual components, like a motor, can be encapsulated in a function block. However, it's just as possible to include entire applications, such as an entire conveyor belt, in a single function block. It doesn't matter which manufacturer made the hardware in the conveyor belt. Everything is automated with that one function block.
Und den kann ich dann wirklich
And I can really put into my new application time and time again without having to revalidate it. That didn't work in the past. I always had to review the entire programming code. The whole engineering process took so much time. But now we can implement the process just like an app, even though it's not really an app store. I can test it and then scale it.
realisieren. Ich teste sie und kann sie dann wirklich skalieren.
The function blocks have another special feature. They don't work in a cyclical system. They're driven by specific events. This means that the function blocks have inputs and outputs for events in addition to their usual data inputs and outputs. As a result, data is only processed when an event signal has been triggered on the function block. This can be demonstrated with the motor in our conveyor belt application. Here we can see the state machine of the motor function block. This is a simplified way of showing how the motor works. When the start signal is given for the motor, it goes into the op left position. It stays in this position until the stop signal comes. Then the stop motor returns to the ready position. If a specific signal is then given, for example by pressing a button, the motor will go into the op right position. The conveyor belt will turn to the right and the package will move back. So, the event flow activates different positions in the code, which then execute the associated code sequences. In most industrial plants today, a cyclic code is only required for a few applications. That's why it makes sense to switch to an event-driven execution model to avoid forcing the rest into a cycle-based system. And there's another reason.
Wir sind da eventgetrieben und nicht zyklisch getrieben.
We're driven by events, not cycles. And, as we know, events are highly compatible with the IT industry. This means that we can open up the possibility of connecting to IT applications.
Möglichkeiten, uns an die IT-Applikation anzubieten.
Once an automated application has been created purely within the software, it has to be transferred to the actual hardware objects. That's where Gregory Bucco and universalautomation.org come into play again, ensuring that the link between software and hardware works for any manufacturer. After all, the software application created in the engineering tool has to run on any operating system, a runtime execution engine.
Dieses Runtime Execution Engine ist ein Teil.
This runtime execution engine is a component that is now common to all manufacturers, and that's exactly what UAO has to offer. We distribute the technology, and our members are responsible for maintaining and advancing it.
Zu warten und auch voranzutreiben.
In short, universalautomation.org provides an operating system compatible with all manufacturers that creates a kind of common ground between components.
Also das Betriebssystem der Hardware, die ich einsetze, muss.
First and foremost, the operating system for the hardware I use has to work according to IEC 61499. Then I'm completely flexible as to what I can run on various parts of each device.
Fachleute, die Fachkräfte müssen nur Kenntnisse.
This means that automation engineers only need to have knowledge of one build time that is compatible with UAO and can deploy it on any hardware. They still need to know things, but they only need to have knowledge of one system as opposed to several systems.
In order to execute the virtual code object on hardware, the code is first linked to a controller. The software application is computed on this controller. Then you have to ensure that signals can be exchanged between the physical objects and the software objects. To do this, you have to configure the input and output signals. If you want to automate an entire conveyor line, more than one conveyor belt, all you have to do is copy the ready-made function block for the conveyor belt. By drawing simple lines, you can connect the interfaces defined in the code and ensure communication between the conveyor belts. The This cross-communication is generated automatically by the Schneider Electric engineering tool shown in this example. One of the key features of IEC 61499 is that the software objects do not have to be computed by a PLC. A frequency converter or any other component with a CPU can also be assigned to a conveyor belt function block. In plants at risk of explosions, for example, this could be a controller from a specialist manufacturer. This makes it possible to give each conveyor belt module its own intelligence, so to speak. However, the different hardware constellations are configured with only one software tool. And that has extensive implications. If any of your hardware components unexpectedly fail, it doesn't matter whether you have an identical replacement in stock. To ensure continuous operation, the code can easily be mapped to another device with a CPU, such as a controller. That can be implemented in no time at all. And if no more controllers are available, the code can also be executed from a server PC. And the system still works, even without a PLC.
Und dieses Deployment ermöglicht dann eben hier, dass ich...
And this deployment lets you distribute your resources better. Depending on the application in question, you might even be able to replace highly complex tasks with devices that require significantly fewer resources. You can also think about swarms. You can think about completely new redundancy concepts. You can even think about load distribution. This means that you can significantly increase scalability, for example, by adding new resources to a machine when extreme demands are placed on it. And you can remove the resources again when they're no longer required, in order to save energy. This means that, compared to old programming paradigms where you had a machine in permanent operation, you can suddenly think much more flexibly about resources, energy consumption, media consumption, compressed air consumption, and so on.
There's a high demand for the flexibility that Professor Schaefer is talking about. For example, R&D departments in the pharmaceutical industry are now using modules called skids, which have to be arranged into new processes tailored to each drug. The quicker and easier that can be done, the better. Gaia has designed its Pathfinder separator for such applications. The device is sold as a single module. It can separate liquids from solids or liquids from other liquids. It can always occupy a different position as required within the overall process. What makes this Gaia separator model so special is the fact that completely universal automation has been used for one of its versions. This can be seen as a proof of concept from Patrick Eickhoff in Gaia for automation according to IEC 61499.
Aber Stand heute haben wir im Grunde genommen wirklich...
As it stands, we have a complete self-contained skid automation module, a mechatronic module, that is mapped in IEC 61499 and is actually operable.
Und auch lauffähig ist.
As an engineering tool is needed to implement such a project, Gaia turned to Schneider Electric. As a manufacturer of automation components, Schneider Electric is very much an early adopter in the field of universal automation. The tech group is the only major company that already has an IEC 61499 ready engineering tool in its portfolio.
Wir können aktuell noch nicht die...
But we can't make a high-end solution at the moment. We're aware of that. But that's what we're working towards. But we can already implement a lot of things related to coordinated applications and PLC technology. And we're offering new ways of transferring data to the IT level.
Auch in die IT-Ebene abzugeben, ne?
In any case, the proof of concept gives Gaia plenty of reason for optimism.
Das Proof of Concept hat im Grunde genommen wirklich gezeigt.
Our proof of concept basically shows that you can develop or engineer an automation solution once, and then use it again and again if the component is compatible with the IEC 61499 standard.
Wenn denn die Komponente 61499 fähig ist, einfach immer wieder verwenden.
For example, we validated basically all of the software, the processes and logic, on the computer or in a virtual environment. And only then did we get to grips with the actual skid. That is the hardware.
Wirklich an das eigentliche Skid, an die eigentliche Hardware angegangen.
The reusability of software modules in particular presents a range of benefits for Gaia.
Als Unternehmen profitieren auf jeden Fall.
As a company, we're definitely benefiting from the fact that we can program something once, do the engineering once, and can then decide what hardware is available or ready for delivery much later in the process.
Die Hardware ist gerade verfügbar. Viel später im Projekt entscheiden.
As far as I'm concerned, we can make this decision shortly before delivery, because then we know that it will work. That's what makes the concept so interesting to us as a mechanical engineering company.
However, the economic potential of universal automation is by no means limited to mechanical engineering.
Also man sieht, wenn man die
If you look at the entire supply chain, you can see that a universal system offers a lot of advantages because you're much more flexible. If you don't use a controller from manufacturer A, for example, you can use a controller from manufacturer B, or an IPC, or sometimes even a Raspberry Pi, which is suitable for industrial use.
oder ein IPC oder sogar manchmal ein Raspberry Pi, weil es industrietauglich ist. Ne?
This obviously opens up a huge amount of potential for companies that are looking to produce more flexibly and economically in the future. We can already see that they'll be able to make significant savings just by enjoying more flexibility and variety in their range of automation components.
Größere Vielfalt bei der Auswahl meiner Automatisierungskomponenten, eben eine wesentlich größere Flexibilität erhalten.
This added value becomes all the more evident when companies want to combine components from different manufacturers. That's because universal automation breaks down the limitations of proprietary systems.
Das sind also Probleme, die in Zukunft wesentlich.
These problems will be significantly reduced in the future, opening up huge potential for savings. I think some studies even predict 20 to 30% savings in the engineering sector, assuming that companies have systems that change regularly, have to meet various new requirements, and want to change their range of products.
Wo ich neue Anforderungen habe, wo ich auch meine Produktpalette ändern möchte.
And there's another point, more relevant today than ever before.
Wir sehen gerade mit dem Thema.
We've noticed that universal automation is an incredibly strong driving force in terms of sustainability. Why is that? Not necessarily in relation to energy consumption, but more along the lines of how you can use your resources more sustainably, how you can become more efficient.
Und da ist natürlich die Ansicht 4.
And that's where IEC 61499 makes it possible to change components relatively quickly during operation and use resources that require or consume less energy. We can respond much more flexibly to load profiles and react much more quickly to fluctuations in the energy grid. We can also optimize our entire supplier network, which significantly enhances our flexibility in production and in the distribution of resources across supply chains. And what makes this standard so exciting is that it doesn't have to be limited to one location. You can also implement IEC 61499 across several locations by building a virtual factory that covers several sites, or even several countries and regions. And I personally find the standard so exciting and interesting that I can imagine dedicating the next 10 to 15 years of my research to it. Because I think this universal approach to distribution is the right path to take if we want to advance automation technology in Germany and the rest of the world in such a way that we can achieve greater openness, flexibility, and manufacturer independence.
If this approach were to spread throughout the automation world, it would undoubtedly bring about a paradigm shift.
Die Frage ist, wie schnell dieser Paradigmenwechsel.
The question is how quickly this paradigm shift will take place and how many markets will support this development. Automation can be found wherever you look in the industry, so you obviously have to teach or present this paradigm shift to a huge market, a huge industry. But it's coming. There's already been a change.
Eine Riesenindustrie diesen Paradigmenwechsel beibringen oder ihn dazu bringen. Aber es kommt. Die Bewegungen sind da.
We need to have a forward-thinking mindset. We almost have to build our systems with one eye on the future. To make you fit and ready for the future, universalautomation.org offers a system where you're no longer tied to a specific manufacturer.
Automation.org diese Möglichkeit quasi herstellerunabhängig jetzt schon zu werden.
I'm absolutely sure that we're taking the right path. Because we've noticed two things. Firstly, IT will definitely change the face of mechanical engineering in the future.
Maschinenbau in Zukunft nachhaltig verändern wird.
And at the same time, we'll be able to combine disciplines to become more efficient. And Universal Automation, or EcoStruxure Automation Expert at Schneider Electric, provides the basis to do exactly that.
Schneider Electric eine Basis dafür, das zu tun.
And the fact that a major manufacturer like Schneider Electric is now using universal automation is something that has never happened since IEC 61499 came out.
Es ist für uns definitiv eine Revolution.
It's definitely a revolution for us. We're taking a completely new approach that opens up a whole host of opportunities, but also brings along its fair share of risks. But it's a really exciting time for us, and we're enjoying it.